Okay, here's the other kind of vertical circle problem. I think maybe these are harder, but maybe they're not. I always go back and forth. Okay. In the previous problem, we figured out the acceleration from the velocity or the period. That'll be the way it works. And then from there, we figure out the force. In this type of problem, I tell you the force either at the top or the bottom. Okay. And this is the trickiest one that we're doing here. Okay. That is the force of downward force at the top, right? They tell you that, and then you've got to figure out what the acceleration is, and from that find the velocity, right? And then figure out the force at the other place, right? Either if I tell you the force at the top, the problem 5 will be what's the force at the bottom. This is not so hard though. So here this thing is, right? At the top, we've got a force downward of 5.75 newtons, right? Remember that we also need to figure out the weight of this thing. So the weight is mg. That'll be the other force acting down, right? So that's 1.2 times 9.81. So let's figure that out. Sorry if I'm not being terribly linear here. 11, so that is 11.772 newtons. Okay, so now we've got 5.75 newtons down. Why? Because it says that it's acting down, right? We've also got 11.772 newtons down, right? So now when we set up our little F equals ma, we can find what the acceleration is at this moment, which will be the centripetal acceleration, okay? The magnitude of it will be anyway. All right, so we go negative 5.75, right? So just be careful. What kids do is they forget that, right? Don't forget that. If it says we're pulling down on it, then or if there's a tension in the string, that gets a little more tricky, right? Well, if it's a tension in a string, you've got to be pulling down. You can't push up with a string. Okay, and then this guy here, this weight is negative 11.772. Gravity is always down, right? And then that equals 1.2 times an acceleration. Now this acceleration will be negative, but its absolute value will be the centripetal acceleration. Okay, so let's plug this in. Let's go parenthesis negative 5.75 minus 11.772 parentheses divided by 1.2. Okay, here we go. The acceleration is negative 14.602 meters per second squared. It's actually 6.6016666. All right. So notice that this is consistent. The fact that that's an acceleration bigger than 9.81 means that we would have a downward force at the top, because that's the way that works, right? Accelerations bigger than 9.8 require a downward force. So now we've got the acceleration. So we're going to say, how do we find the velocity? Well, we'll say a is v squared over r. Sometimes I ask for what the period is, so then you'll say a is 4 pi squared r over t squared, right? So just be resourceful there, right? Okay, and then I'm not going to put the minus sign in there because I'm just not going to. Okay, so 14, because the centripetal accelerations are never negative. What would that mean? Okay, is v squared divided by 0.045. Or 0.45, sorry. Okay, so clearly I'm going to go this times okay, and then I'm going to take the square root. So this times this, take the square root of that, so raised to the 0.5. I need 2.563. Yay. Oh, that's meters per second, right? So we've got that, right? In part 4, we're going to use this acceleration, right? Okay.